In electronics and radio communications and many such fields, we encounter discrete packets of energy or packets of mass or packets of waves. And in all of these applications, we come across a very peculiar type of function called the box function, or the flow function, or what is technically called the greatest integer function. So let us look at this standard function, which is called the greatest integer function. The greatest integer function is denoted by x surrounded by this box brackets. So that's why sometimes it is simply read as box of x. And what is this equal to? It is equal to the greatest integer less than or equal to x. So therefore this is equal to n minus 1, where x is between two integers n and n minus 1, or it is simply equal to n again where n is an integer. For example, if we have x is equal to 2.5, then box x will be equal to 2. On the other hand, if we have x is equal to say minus 1.3, then box x is equal to minus 2, because minus 2 is less than minus 1, and minus 1.3 falls between minus 2 and minus 1. Similarly, 2.5 falls between 2 and 3, and therefore box of 2.5 is equal to just 2. So the graph of the greatest integer function looks like this. Why? Because for all real values of x between any two integers, it is always the constant value which is equal to the lower limit of that interval. For example, for all values between 1 to 2, box x equals 1. For all values of x between 2 to 3, box x equals 2. For all values of x between minus 3 to minus 2, box of x will be equal to minus 3, and so on. And that is why the graph results into a very regular shaped figure like this, which looks like a flight of stairs looked at from a cross section point of view. And therefore the greatest integer function is also called the step function. So this function presents a very interesting problem when we apply it to trigonometric functions or exponential functions or logarithmic functions, and therefore a mix of logarithmic functions and greatest integer functions presents very interesting results. We'll look at that in the following examples. But before that, we have to study some properties of greatest integer function. So if x is some real number, not any real number, a integer, then modulus of x is going to be less than or equal to x, and it is going to be greater than or equal to x minus 1. Modulus of x plus or minus n, where n is an integer, is equal to modulus of x plus or minus n. Modulus of x greater than or equal to n implies that x is greater than n, as also vice versa. For example, box of 2.5 is greater than or equal to 1, obviously, because box of 2.5 is 2. This also implies that 2.5 itself is greater than or equal to 1, which is true. Similarly, box of minus pi, for example, is greater than or equal to minus 4, because minus 4 is to the left of minus pi. So therefore, this implies that 3.14 is less than or equal to 4, which is true. Next property of greatest integer functions: if box of x is greater than n, then x value, the actual value of x, is greater than or equal to n plus 1. For example, x is equal to 7.5 and n equals 9. This means that box of 7.5 is greater than 9. That is 7. Next property: if box x is greater than or equal to a particular integer n, then x itself is greater than or equal to n. It's not always obvious, as we can see from this example. X equals 5.4, n is equal to 3, so that you get box x is equal to 5, and that is greater than or equal to 3, right? That means 5.4 is greater than or equal to 3. Let's take the case of negative numbers. X is equal to minus 5.4 and n is equal to minus 5. In this case, how is it? This case does not satisfy. So let's take this as minus 6. So therefore, we get box of x is equal to minus 6, and minus 6 is actually equal to minus 6. So therefore, we get minus 5.4 is greater than or equal to minus 6. See how close it can get? That's why. Similarly, if box x is greater than n, then x itself is greater than the next integer to n. For example, if x is equal to 2.75 and n is equal to 1, then box x is equal to 2 is greater than 1. Therefore, 2.75 is greater than n plus 1, which is equal to 2. So therefore, 2.75 is also greater than 2. Similarly, if x is equal to minus 2.75, then n is equal to minus 2. Then this is not the case. Box of x is equal to minus 3, and minus 3 is less than minus 2. So let's take n equals to minus 4, and minus 3 is greater than minus 4. Therefore, minus 2.75 is greater than or equal to minus 4 plus 1. That is, minus 2.75 is greater than minus 3.